So, hello, good day. So, for this discussion, we will be talking about the classification of soil. So, different soils with similar properties may be classified into groups and subgroups according to their engineering behavior. Classification systems provide a common language to concisely express the general characteristics of soils, which are infinitely varied without detailed description. So, most of the soil classification systems that have been developed for engineering purposes are based on simple index properties such as particle size distribution and plasticity. So, although several classification systems are now in use, none is totally definitive of any soil for all possible applications because of the wide diversity of soil properties. So, in the previous discussions, no, in the previous modules or in the previous topics that we have discussed, we have defined um, the physical properties of soils. No, we have the unit weight, the weight and volume relationships, no, such as unit weight, the void ratio, porosity, degree of saturation, and before that, we have also talked about the grain size distribution of soils. The part where we have identified, no, in our soil sample or in our soil mass. Um, we have learned how to identify the percentages, no, of gravel, sand, or silt and clay. And we've also studied the plasticity of soil, which is also a part of the engineering properties or the index properties of our soil. So this time, using those properties, no, the grain size distribution and the plasticity in specific, we will now be classifying soils, no, according to their properties or their behavior, because we know each soil varies good from one place to one place. So that's why there may be soils that have the same qualities or the same properties, and there may also be soils that are composed of diverse or different or varying properties. So soil classification is basically the grouping of soils with similar properties. Okay, so why do we need to classify soil? So, in engineering, it helps us in determining the number of building and landscaping limitations on any particular piece of land. So, soil classification is essentially the methodology involving the separating of soil into classes or groups which have similar characteristics. So, soil classification has also an impact, no, in agriculture aside from in the engineering. So, in agriculture, the knowledge of soil classification helps predict soil behavior. Soil behavior helps predict soil performance for growing agricultural crops. So, by classifying soil, we now can predict or somehow have an idea of how this type of soil that we have will behave, no, in accordance to a lot of factors, no, in a given situations during the agricultural production. So how will the soil behave so that the farmers, no, can already provide solutions if there are cases nga needed yun siya, no. So that's why soil classification is also important to study the behavior of soil or simply get to know the type of soil that you have. Okay, so there are several ways in classifying the soil, no? We have first the uh, textural classification. We have the classification by engineering behavior, which includes the AASHTO classification system and the Unified Soil Classification System. So these are the established systems, no, on how we classify our soil. So let us take them one by one. first, we have the textural classification. So, in a general sense, texture of soil refers to its surface appearance. So, soil texture is influenced by the size of the individual particles present in it. So, we have here no, a table for the textural classification systems by the USDA. This classification was already discussed or somehow presented in the first topic no for module 1, which is the soil formation, because in there we have studied or we have discussed the soil particle sizes and how do we classify the different particle sizes in our soil, and one of which is the USDA no. So this is the graph or the figure that we will be using in order for us to classify or determine what type of soil that we have no, in reference with the particle sizes or the texture of our or the textural characteristics of our soil. So, a number of classification systems were developed in the past by different organizations to serve their needs, and several of those are in use today. So, figure here shows the textural classification systems developed by the US Department of Agriculture. So this classification method is based on the particle size limits as described under the USDA system in the previous discussions, no. So basically kaning textual classification, yang ginagamit lang is the particle sizes limits of our soil. So according to the USDA, no, sand size belongs to 2 millimeters to 0.05 millimeters in diameter. So however, in our previous discussion for soil formation, no, or soil particle sizes, in the example presented, we have used the USCS classification system for. But in here, no, to explore other standards and other systems, we will be using the USDA system, no, for the particle size limits. So for the silt size, according to the USDA, it is of the size of 0.05 to 0.002 millimeters in diameter, and then clay size are those particles that are smaller than 0.002 millimeters in diameter. So we can see here no the percentage for clay and the percentages of silt and the percentage of the sand. So all you have to do is pick no from this. For example, we will have this problem. According to the given, we have here sample A, which is consist of 30% sand, 40% silt, and 30% clay size particles. So, in the texture classification by the USDA, so first we have to identify the or we have to project the percent sand in this table or figure. So, we have here in the percent sand, no? 30 daw siya. So, we have here the 30. And then, we will have to project, no? This diagonal line from the 30 nga percentage atong sand. So, ato lang na siyang sundon, ana. And then, the next, we have to project na pod the percent silt, which is equal to 40. So, muna siya diri, no? Atong circulan. And then, the same thing that we did for the sand, we will project that line, no? Corresponding to this percentage rather. So same as true with the percent clay, no? Percent clay according to the given is 30%. So if you're going to project that line that belongs to or that corresponds to the 30% clay, that is what we will going to have. And then if we are to identify the intersection of all of these three lines, mo na siya, no? And then, naman siya mga subdivision diri, no? So, kung diri lugar ma-fall ang imuhang point of intersection, meaning sandy clay siya, and then kung diri sandy clay loam, kung diri sandy loam, kung diri sand, silt, silty loam. So, this time, in the given, no, in the soil sample, na-fall ang atong soil sample A under the division of clay loam. So, therefore, Our soil is clay loam, no, is classified as clay loam. So, ana lang siya kadali gamitan ng texture classification, no, from USDA. Okay. Note that this chart is based on only the fraction of soil that passes through number 10 sieve. So hence, if the particle size distribution of the soil is such that a certain percentage of the soil particles is larger than 2 millimeters in diameter, a correction will be necessary. So, what is this trying to tell us? It means that we can observe, no, in the soil particle sizes, we have four man unta to, no, gravel, sand, silt, and clay. Pero ang kaning textural classification, ang yang i-cater lang ang mga percentage is the clay, the silt, and the sand. So luckily, no, or fortunately, in the given, mura sad pod ang gina-consist sa atong soil. Sand, silt, ug clay lang siya. So, iyang ginapasabot dire is ang larger than 2 millimeters diameter is the gravel man. So, swerte na lang, no, kay diri sa atong sample wala man siya gravel fraction. So what if daw, no, in a soil sample naa daw gravel percentage? So we would have to make a correction for that. So how do we do that? We have here another example na soil B. So, ana siya, nanda siya 20% gravel, 10% sand, 30% silt, and 40% clay. So, we have first to make a correction, no, or modification. So, how do we do that? So, first we have the sand size. We have the percent composition times 100 over 100 minus the percent for gravel, no? So, as you can see, in the three soil particle sizes, the sand, silt, and clay, constant ni siya diri, no? 100 minus 20 ang denominator, and then 100 minus 20 po dira, 100 minus 20. So, kaning formula diri is actually 100 minus the percent fraction for gravel, and then the same lang din dire, no, 30% times 100, no, for the silt, and the 40% for clay, it which is given times 100. So all you have to do is compute for that and then proceed with the same procedure that we did in soil sample A. So we just have to project, no, since 12.5 man siya, so bungkig, so it maybe is somewhere here, no. So ato na siya mag-project tag line there ha. And then for the silt size, no, is 37.5. Bungkig po siya kay it's somewhere between 30 and 40. So mag-project lang ta somewhere dira. And then as well for as the clay size, it is 50 luckily, no, kay dili siya bungkig. So at least nagid siya diri sa iyahang calibration. So for 50, no, clay percentage, so we have to project that. And then ang ilaha da yung in point of intersection belongs to the division of clay. Makita nato dali, no? So, meaning, we can classify our soil as a clay. Pero, however, we need to take into account pod the percent, no, nga 20, which correspond to the percentage of gravel present in our soil. So, with that, no, because of the large percentage of gravel, it may be called gravelly clay. So, mo lang na siya, no? That is how we classify our soil using textural system, no? We have presented here the system followed by the USDA, so US Department of Agriculture. So, we can notice, no? It has not taken into account the plasticity properties of our soil, but we will be tackling that on our next discussions or discussion of other systems. So, classification by engineering behavior, no? Although the textual classification of soil is relatively simple, it is based entirely on the particle size distribution. So, wala mo talaga gamit itong other factors, no? Ang katarag yung particle sizes distribution sa atong soil. So, the amount and type of clay minerals present in the fine-grained soils dictate to a great extent their physical properties. Hence, the soil engineer must consider plasticity also, which results from the presence of clay minerals to interpret soil characteristics properly. So because textual classification systems do not take plasticity into account and are not totally indicative of many important soil properties, they are inadequate for most engineering purposes. So currently, two more elaborate classification systems are commonly used for soils engineers. Um, Both systems take into consideration the particle size distribution and the Atterberg limit. So they are the American Association of State Highways and Transportation Officials, or the AASHTO, and the Unified Soil Classification System. So the AASHTO soil classification system is used mostly by state and country highway departments. So geotechnical engineers generally prefer the unified classification system. So these two classification systems will be discussed no, in our succeeding um, slides. So first, let us talk about the AASHTO classification system. So the AASHTO system of soil classification was developed in 1929 as the Public Road Administration classification system. It has undergone several revisions, with the present of the version proposed by the Committee on the Classification of Materials for Subgrades and Granular Type Roads of the Highway Research Board in 1945, so ASTM designation D 3282 and the ASH to M, I method M 145. So, mo ni siya ang mga provision no, for soil classification under AASHTO system. So, ang AASHTO classification system uses this table, no? Table 1. So, AASHTO classification in percent use is given in table 1. So, this table, no? According to this system, soil is classified into 7 major groups. We have the A1 up to A7 soils. To A7 the nga major group. So, soils classified under groups A1, A2, and A3 are granular materials, of which 35% or less of the particles pass through the number 200 sieve. Soils of which more than 35% pass through the number 200 sieve are classified under the groups A4, A5, A6, and A7. So these soils are mostly silt and clay types. So as we can see here, no, in the first group of table, no, we have we have here the granular materials, which means 35% or less of the total soil sample passing number 200. So ang passing ko no, sa number 200 is 35 or less. We will be using this part. And then if the percent passing for our sieve number 200 is more than 35%, meaning we have sealed clay materials, no, fine grain siya, and then we will be using this part here. So this classification system is based on the following criteria. So we it takes into account the grain size, gravel, okay, fraction passing the 75 mm sieve and retained on number 10. It also takes into account the sand, no, which is the fraction passing the number 10 and retained on number 200. And of course, the silt and claying fraction, which is the one passing the number 200 US sieve. So it also takes into account the plasticity, no. It is included in the classification of soil, the plasticity properties of our soil. So the term silty is applied when the fine fractions of the soil have a plasticity index of 10 or less. So the term clayey is applied when the fine fractions have plasticity index of 11 or more. So if cobbles and boulders, no, those with sizes larger than 75 mm are encountered, they are excluded from the portion of the soil sample from which classification is made. So, however, the percentage of such material is recorded. Okay, to classify a soil according to this table, na, one must apply a test from the data from left to right. Kato kaganihan, no? Magbase ka to from the left column, leftmost column, padulong sa right. Katong table 1 nag-represent kaganiha. By process of elimination, the first group from the left into which the test data fit is the correct classification. So figure 1 here, we also have another table that our AASHTA classification system uses. So it shows a plot of the range of the liquid limit and the plasticity index for the soils that fall into groups A2, A4, A5, A6, and A7 to evaluate the quality of a soil as a highway subgrade material. One must also incorporate a number called the group index. So, appeal po siya, no? You also have what we call, aside from naming it A7 or A1 and whatsoever, we also have what we call the group index. Now, we also have to indicate that. So, this index is written in the parentheses after the group or subgroup designation. So, the group index is given in the equation 1. So, we also have here, no? F sub 200 is the percentage passing through number 200. Okay, so percentage na siya di ano, minus 35 times 0.2 plus 0.005. LL here is the liquid limit minus 40 plus 0.01, and then F200 is still the same, no, percent passing in our sieve number 200, and then minus 15 times PI, which is the plasticity index. Now we know the plasticity index is equal to LL minus PL, and then minus 10 lang dayon. So that's how we compute or we identify our group index. Okay, so the first term of equation 1, kataganihan, no, that is for F200 minus 35, no, muna siya, no? Is the partial group index determined from the liquid limit? Kay ka-contain man siya sa liquid limit nato nga value, no? And then the second term, that is 0.01 rather, F200 minus 15. Tapos, it contains the value of our PI. That means it is the partial group index determined from the plasticity index. So, following are some rules, no, for determining the group index. So, if equation 1 yields a negative value for our group index, it is taken as 0. So, the group index calculated from the equation 1 is rounded off to the nearest whole number, no? For example, we would come up with the value of 3.4 for our group index. That will be rounded up, or that will be rounded off to 3. Okay? If it is 3.5, and then it will be rounded off to 4. So, another rule is there is no upper limit for the group index. The group index of soils belongs to A1-A, A1-B, A2-4, A2-5, and A3 is always 0. So when calculating the group index for soils that belong to groups A2, A2-6, and A2-7, use the partial group index for PI or equation 2. Kanilang daw ang gamiton, no? If our soil belongs to A26 and A2 A27. So, gamitin doon natin siyang equation for us to solve for our group index. So, in general, the quality of performance of the soil as a subgrade material is inversely proportional to the group index. So, the lower the group index, the better material or the better the quality of our soil as a subgrade material. So, the higher the group index daw, meaning it is or it has a low quality as a subgrade material for our pavement. So we have here, no, a sample problem of soil containing its data, no, and then we will classify it according to a ash to soil classification. So the results of the particle size analysis, the sieve analysis na siya, no, of a soil are as follows. So percent passing number 10 is 100, percent passing number 40 is 80, percent passing number 200 sieve is 58. So, the liquid limit of the plasticity index of number 40 fraction of the soil are 30 and 10. So, ang LL daw is 30 and the PI is 10, so respectively. Classify the soil by the AASH2 system. So, solution, no? Using table 1, since 58% of the soil is passing through number 200 sieve, it falls under the classifications. So, muna itong gamito, no? Kay duha man ni siya, no? Ang katong granular material, kung 35% or less, ang atong um, percent passing sa atong sieve number 200. Pero however, in this problem, it says that the percent passing for our sieve number 200 is 58. So that is more than 35. So we will be using this table or this part of the table. So using table point 1, no? It falls under the silt clay classifications. That is, it falls under the A4, A5, A6, or A7. Proceeding from the left to right, it falls under group A4. So, from here, no, sieve number 200 daw ang passing is 36 minimum. So, okay, sulod, no? O that is at least 36%. So, sulod ato, since atong percent passing for number 200 man daw is 58. So, naata diri, no? And then, so, diri sa ta mag-una. And then, for the liquid limit, pila man ang atong, actually, sa A4, A5, A6, A7, A7, A75, and A76, 36 raman ang minimum sa atong percent passing sa number 200. So, sulod pa siya sa tanan, no? And then, for the liquid limit, asa man na fall ani ang atong given, no? Our liquid limit is 30. So, asa man siya na belong. Dili siya pwede sa 41 minimum, no? Kay 30 raman siya. So dili na ta x na ta din sa kaninga column. So ang nabil na column is 40 max. So ang atong, which is sulod gyapon siya sa duha, no? 40 percent passing 40 ang value daw sa atong LL, which is atong value is 30 man. So sulod siya aning duha. So let us continue, no? So, X na kibali ning A5 o kaning last column. So, the plasticity index is 10. So, we have here 10 max and 11 minimum. So, gawas na siya diri, no? X na po ni diri. So, since kaganiha diri, okay pa ta diri, dili na ta okay diri, no? Sa ato na siyang crush out. Kani di ito. So, pag abot diri, the plasticity index, sa between sa duha sa A4 o A6, no? Sa 10, dili na lang na fall ang atong value for our plasticity index, which is 10. Kaya ano siya, 10 daw ang maximum. Pero dili sa A6, 11 man daw ang minimum. So, dili na ta po, dili pwede. So, X na ta diha, no? So, ang nabili na lang yun is this one. So, meaning, our soil belongs to the group A4. Muna siyang A4 siya. Kay by elimination man to pinakauna, no, diri ta namili ta. So recapping, no, sa atong pag-classify sa atong soil. First, we did the percent passing number 200, ana siya ang classification kuno sa tanan is 36 minimum. So sulod ta tanan, no, so okay pa ta di kaganiha. Atong i-consider is kaning upat pa ka column. And then diri na sa atong liquid limit, ana siya is ang atong value is 13 na lang man. Then sulod siya diri sa 40, so check na siya din na. Pero diri is 41 man ang minimum, so automatically dili na ta kapadayon diha nga column kay wala naman siya ni sulod, no. So for A6, 40 kuno ang max sa liquid limit, meaning sulod ato so okay ta diha nga part, no. And then sa atong A7 and this last column ana siya kuno 41 daw ang minimum nga value sa atong liquid limit, which is dili na pod kasulod ng atong given. So that's why automatic crash out na siya. And then for the plasticity index, ang ni okay lang diri is ang A4 lang. Kay duha na lang ka column, no, ang wala na X, which is the column for A4 and the A6. And then the A6, ingon siya, yung requirement for plasticity index is 11 minimum, pero 10 na lang man ang atua. So, dili ra gyud siya nisulod sa A4. That's why ang classification sa atong soil is A4. Now we will be solving for our group index, no? So our group index from equation 1, we have here the formula, and then we just have to substitute the value for our LL, which is 30, and the percent passing for 200, which is 58, no given, and then the PI, which is 10, and then the actual value for our group index is 3.45, and then we were advised, no, or it is in the rule that we have to round that off, so we will be rounding that off to 3. So therefore, our soil will be classified as A-4 with a group index of 3. So that is how we indicate our group index, no, in parentheses siya after the group of our soil. So that is how you classify your soil according to a AASHTO soil classification system. So now let us go to the third part of our classification systems, no, which is the unified soil classification system. Okay, unified soil classification, no. The original form of this system was proposed by Casa Grande in 1942 for use in the airfield construction works undertaken by the Army Corps of Engineers during World War II in cooperation with the U.S. Bureau of Reclamation. This system was revised in 1952, and at present it is used widely by engineers, no, and its ASTM designation is D2487. Okay, so the unified classification system is presented here in table 2. So, same sila, no, sa atong AASHTO soil classification system, which relies on the tabular information. So, the system classifies soil into two broad categories. We have the coarse grained soils that are gravelly, no, and sandy in nature with less than 50% passing through number 200 sieve. So, the group symbols start with the prefix G or S. G stands for gravel or gravelly soil, and S stands for sand or sandy soil. So muna yung pasabot diri, no. Duha gyapon ka subgroups ang kanisang ang sa USCS, di ba? Kaganiha sa ASH to duha gyapon to, coarse grained and then fine grained. Pero lahi lang siya og provision, no, kung unsa or requirements para mabilong siya either of these group of soil. So we also have the fine grained soils, no, kaninga part diri are soils with 50% or more passing through the number 200 sieve. Madadari, nakasulat siya. The group symbol starts with prefix M, which stands for inorganic silt, or C for inorganic clay, or O for organic, mo itong makita dari ang mga symbol. O for organic silts and clay. So the symbol PT, na dari sa last, is used for peat, muck, and other highly organic soil. So other symbols used for the classifications are R, W, well graded, P, poorly graded, L, low plasticity, no, with liquid limit less than 50, and then high plasticity, which is denoted by capital letter H, with liquid limit more than 50. So basically, we will be using this table for classifying our soil under USCS. So, the same gyapon, no, sa atong AASHTO, naa gyapon siya plasticity chart, katong kaganiha gyapon, no, the same. For proper classification according to the system, some or all of the following information rather, no, must be known. We have to know the percent of gravel, the percent of sand, and then the percent of silt and clay, and the uniformity coefficient Cu, and the coefficient of gradation Cc. Liquid limit and plasticity index, of course, has to be known. So, the group symbols for coarse grained gravelly soils are GW, no? Start sila sa G. Similarly, the group symbols for fine grained soils, kay mao ni sila, no? So we have here a sample problem. For a given soil, the following are known. So person passing for number 4 sieve is 70. For number 200 sieve is 30. Liquid limit is 33. And plastic limit is 12. So classify the soil using the unified soil classification system and give the group symbol and the group name. So ang USCS no kay ayang gagamitin is katong mga group symbol katong mga GW, mga CS, mga SC no. Whereas sa ASH to, yung gapanggamitan dito A-4, A-7, so mo na yung kalainan nila no. So we have here no atong i-present ang kaning table sa USCS apil iyang plasticity chart. So refer to table 2 no, the percent passing in number 200 is 30. So which is less than 50. So atong gamiton is coarse grained soil. So dili ta magtan-aw. Okay. So coarse fraction which is 100 minus 30 is 70. So gravel fraction percent retained on number 4 is 100 minus 70, that is 30%. Hence, more than 50% of the coarse grained is passing number 4 sieve. So para diri no, mamili ani diri nga kay same nagyapon ang movement padadto gyapon. So from left and then to right. So from the left, we have here to identify the percent retained on our sieve number 4 para makapili ta aning duha between the gravel and the sands. So according diri, no, 30% daw ang percent retained sa atong sieve number 4. So more than So diri ta kibali, no? Ang percent retained man daw is 30%. So meaning ang percent passing ana is 70. So diri siya na fall no sa atong sands. So meaning this is a sandy soil. And then diri sa ikaduha no, since more than 12% is passing number 200 which is actually given, it is SM or SC. So dili ta makagamit ani diri no nga kanang mga classification sa CU o CD nato kay ang diri sa under sa sands duha lang man ang pilian nimo, clean sands and sands with fines. Since ang atong percent passing for sieve number 200 is more than 12%, so dili ta mag-refer no sands with fines. So dili na ta kaning SM ug SC. Then how do we choose between SM and SC? It is through our PI. So kung ang PI ko is less than 4, your soil will be SM. And then if your PI is greater than 7, then your soil is SC. So we have man the given LL or liquid limit is 33 and our plastic limit is 12. So our PI for that is 21, which is greater than 7 and not less than 4. So dirita no. Therefore, our soil is SC. Okay? And now for the group name, since the percentage of the gravel is more than 15%, it is clayey sand with gravel. So mag-refer din ta diri no. So SM man na ato aganiha ay SC. Clayey sands, but since our soil actually contains gravel, that's why it's called clay clay sand with gravel. So that is how we classify soil, no, in accordance with the USCS or the Unified Soil Classification System. Very dependent ra gyapon siya ani nga mga data nga nasa table, no, and then elimination process lang gyapon kung mamili ka sa duha ani, and then, for example kani ang napilian, and then mamili din ka sa ilahang duha. So kung for example kani ang napilian, and then mamili na pud ka ani sa ilahang duha, and kung unsang mapilian sa ilang duha kung asa na bilong, no, asa na fall ang atong given, so mo na din imong pilion sa ilaha nga soil classification with the group symbol and the group name. So that All right, so that would be all for the discussion of our soil classification, no? I hope you were able to grasp the idea of how each of these or how each of the three classification systems classify our soil no unsay nagkalain-lain nila nga pamaagi in classifying our soil in respect to their respective um, physical properties or index properties no ang for example ang textural classification ginaunsa niya no og unsa iya pong mga codes or group names ang ginagamit as well as the AASHTO and the USCS syempre kanya-kanya magsilag pamaagi no and then although these classification systems are widely used around the world no dili lang man ang isa lang ang mas ginagamit pero ginagamit or gina-adapt gid ni silang tulo so it's very important for us to know how to use these classification systems no so I think that would be all for now and thank you so much.